Okay, so let's pick up with number 4. Which expression is equivalent to x to the 1/2 times x to the 1/2 over x? So you have to use your knowledge of properties of exponents here. What did we do in lesson 2 when I had x squared times x to the 3rd? When these bases are the same, I add the exponent. So this would be x to the 2nd times x to the 3rd. This would become x to the 5th because this was x times x times x times x times x, and that's x to the 5th. So we know that we add those for a shortcut. So this is the same concept. I have an x and an x, which is the same base. So I'm going to add 1/2 plus 1/2. And 1/2 plus 1/2, when the denominators are the same, you keep the denominator and add the numerators, so you get 2 over 2, which is 1. So x to the 1st over x. Now I don't have to write that to the 1st because it's an exponent of 1. But what is x to the 1st over x? Well, x to the 1st over x is the same as x over x, which something over itself is always going to be 1. So your answer here would be 1. And remember, you can also take, since these bases are the same, you could do x to the 1 minus 1, which is x to the 0. But remember, anything to the 0 power is always 1. Okay, let's look at number 5. Alright, number 5, I would like you to pause the video here and try to do this by yourself before I help you. Remember, you could use some shortcuts as using these as multiple choice. Take your time and see if you can do it. So pause now, and then you can watch the solution in just a second. Okay, so let's go ahead and do this one. So you have to find an equivalent statement to this. So the first thing that I'm going to do is I'm going to change this back to a radical statement, because I can understand the radical a little bit better when I'm reducing. It looks more familiar to me. So remember, this goes to the index number, and then the ones are the exponents, so it's just going to stay the same underneath the radical. So now I'm going to reduce. So I'm going to come over here in blue and do 16 and reduce, or break 16 down, which is 4 and 4, and then 2 and 2, and 2 and 2. So I have 4 2's underneath there. So I'm going to have the cubed root of 2 times 2 times 2 times 2. Then I have x to the 4th, y to the 3rd. So I'm going to go ahead and reduce there. So I take groups of 3, remember, because the index is a 3. So there's a group of 3 2's. So I'm going to pull a 2 out in front. And as far as the number goes, I would have a 2 left inside. And then I would have x to the 4th, which is 4 x's. That would be one group of 3. So I would pull 1 x out and then leave 1 x in. And then if I have 3 y's under the radical, if I pull groups of 3, I'm going to have 1 y left on the outside. Okay. So now you can't look now to see if you can eliminate, because I still got to multiply it by this one. So I'm going to change degree now. I'm going to do the cubed root of 4xy to the 5th. Okay, so now when I do that, I have to have groups of 3. So if I break 4 down, I have 2 times 2. So underneath here, I'm going to have the cubed root of 2 times 2, and then x and y to the 5th. Notice I do not have a group of 3's here. So I cannot pull anything out here. So I'm going to have the cubed root of 2 times 2. I'm leaving that way for a reason. And then x, I only have one of them, so I can't pull 3, so I have an x left. And then y to the 5th, I have 5 y's, so I can pull 1 y out, and I would have 2 left inside. Because 5 divided by 3 is 1 remainder 2. So there's 1 remainder 2. So I can clean this up just a little bit. Everything on the outside, remember this is commutative property, so I can multiply, this is multiplication, so commutative property holds. So this could be changed to 2xy to the second, because y times y would be y to the second. And then since this index number is the exact same as this index number, I could write those together. So 3 as the index number, and then you'd have 2x from here, and then times 2 times 2xy to the second. Well, now what could I do? Well, now I still have an index of a 3, so I still have 3 2's. Now I have 3 2's in there, so now I could pull another 2 out. So I have a 2 here. This 2 would come outside. I would have xy to the second. And then in the radical, I would have the cubed root of, and then this x and this x would go together, but I only have 2 of them, not 3, so I couldn't pull another one out. And then y squared. Oh, and y is the same way. I have 2 of them, not 3, so I couldn't pull one out. So what is that equivalent to? Let's look at our choices up here. Well, I know it's not A because there's not a 4 left on the inside. B looks the same as A. I have a number on the inside here, so I would throw that one out. And then this one is going to be the answer, because 4xy to the second, 2 times 2 is going to be 4. Xy to the second holds, and then you have the cubed root of x squared, y squared. So C is the answer there, because it matches this. So once again, to recap on that one, if these index numbers are the same, I can put them together all under one radical. Okay, let's look at number 6. Go ahead and pause the video, see if you can do that one without me. Okay, now I am going to change this to a radical form. So I'd have 9x to the 5th, y to the 6th, because the denominator becomes the index. Since the index is a 2, now I have to find groups of 2. I'm going to break 9 down to 3 and 3. So under the radical here, I would not have to write that index of a 2. I'm just doing it to remind you that you're taking groups of 2. It's not really needed. Now I'm going to go ahead and group groups of 2. So I have 2 3's. So that's going to come on the outside, and now I'm just going to lose the 2. And then if I had 5 x's, 5 divided by 2 is 2 with the remainder of 1. So this 2 becomes the exponent here, and then I have an x with the 1 exponent. And then y to the 6th, 6 divided by 2 is 3. So I would have y to the 3rd on the outside with no remainders on the inside. So which one's your answer? Which one looks exactly the same as that? And that would be C. Okay. Let's look at number 7. Which expression is equivalent to this? Well, you notice you have x to the 2nd and y to the 3rd, and you have an index of 4. So you know you can't pull groups out because there's not enough x's nor y's. So I'm just going to see how I can rewrite this. So the first way I know to rewrite this, if I can have x to the 2nd, y to the 3rd, raised to the 1/4 power. And is that an expression? Yes, here's the answer. D is going to be your answer there, because that's the one that matches it. Now, they could have went one step further, maybe in a possible other one. They could have done x to the 2nd times 1/4 and y to the 3rd times 1/4, because this is a power to a power. So 2 times a 4th would be x to the 1/2, because that would be 2/4 equals 1/2. And then this would be 3/4, so y to the 3/4. So either way, this is also equivalent to D, but obviously they're not going to have both of these choices because they're equivalent. So D is the only choice there. Okay, let's look at 8. Okay, go ahead and pause the video, see if you can do that one by yourself. Okay, now we're multiplying here. So since I'm multiplying all the way across, these two are pushed together and these two are pushed together, and there's a dot in the middle. I can move things around. So 2 times, now it would be logical to put the 3 by that because they're both coefficients, x to the 5/4 and x to the 1/4. So go ahead and multiply 2 times 3, which is going to be 6. Do not get confused and add, because see, the trick ones are the 5s. So you're going to multiply there. You add if you have exponents that have the same basis. So here I have x to the 5/4 times x to the 1/4. So when I have that, that's just like this problem again. Bases are the same, so you add the exponents. So I'm going to add 5/4 plus 1/4. The denominators are the same, so I keep 4. Add 5 and 1, which is 6. So that is 6/4, which reduces to 3/2. So I have x to the 3/2, which is not a choice over here. But you notice I'm in radical form here. So I've eliminated A and C because they have 5s. So which one's equivalent to 6x to the 3/2? Well, this is an index of a 2. X to the 3 can go like that. You have to know that denominator becomes the exponent. The denominator becomes the index. So your answer there will be B. Remember, I don't have to write an index number of a 2. Okay, and the last problem is which expression is equivalent to the square root of 54x to the 9th. So go ahead and pause the video, see if you can complete that one. Okay, and now we're going to break 54 down. 54 becomes 6 times 9. 6 becomes 3 times 2. And 9 becomes 3 times 3. So underneath that radical is 3. I'm going to put all my 3's together. And then next to the 9th. So I'm taking groups of 2 because the index is a 2 here if it's not written. So I have a group of 3's there. So I'd pull a 3 out. And then the square root of 3 times 2 stays on the inside, so that's going to be 6. And if you're pretty confident with the numbers there, you're done. Because if I've done that correctly, that's the only possibility, because that's the only one with 3 on the outside and 6 in the radicand. Alright, but just to show you how I do that, if it's not multiple choice, I have x to the 9th, so that's 9 x's in there. So I could write x 9 times. I don't suggest that because it takes a lot of time, but if I'm taking groups of 2, that's pretty easy. So I have 4 groups, so x to the 4 is going to be on the outside. You're going to have 1 x on the inside. That's the same as doing 9 divided by 2, which is 4 remainder 1. So x to the 4, and then there's your remainder 1. Hope that helps, guys. Now you need to complete that practice activity. You have 3 attempts on it, so do your best, show your work, make sure you're doing what you know, just as I did on this video. It's going to help you just to rewrite the terms and then try to simplify. Good luck.